Calculating density requires two measurements, mass and volume. Mass can be measured on the scale using grams, and volume is a measurement of how much space something takes up. One way to measure volume is to use a graduated cylinder. This is really good for measuring the volume of liquids. You can also measure volume of a regular object using a ruler and measuring the length, width, and the height, and then you can calculate the volume of this cube. That would be another way. Let's examine how to find the volume of this regular shape. So this is a cube, and you can clearly see that my large cube is made up of small ones. So we can look at just one of them and measure it in centimeters. If we measure it in centimeters, we'll see that one side of it is clearly 1 centimeter, and another side would be 1 centimeter, and the last side would also be 1 centimeter. This cube is a cubic centimeter. That means the volume of it is 1 centimeter by 1 centimeter by 1 centimeter. And if we multiply all of these together, we end up with 1 centimeter cubed. That's the volume of this cube. So if we know the volume of one of these is 1 cubic centimeter, we don't necessarily need to measure the sides of this. We can just count how many cubes there are that make up this cube. So we have 1, 2, 3, 4, 5, 6, 7, 8, meaning that the volume of this cube is 8 centimeters cubed. Using a cubic centimeter is a way that you can estimate the volume of irregularly shaped objects. This is called SWAG. SWAG stands for Scientific Wild Ass Guess. So using my cubes, I can line them up and say this has a height of about 6 centimeters because I know each one of these cubes has a length of 1 centimeter. And then I can kind of estimate how wide it is. Maybe 1, 2, 3. So it would roughly take about 18 of these cubes to be the same size. So something a little bit like that. Similar, but you can see it's not quite the same width as it. So I'd maybe have to add another row. So something like this is similar in volume. Now, this is an estimation. There is a more accurate way to find the volume. To calculate an accurate density of this, we'll use a different way. The first thing that we'll want to do is take the mass. So I'll put that down on the scale. I have a mass of 58.07 grams. The next thing that I need to do is measure the volume. The way to measure the volume of this object is to do something called water displacement. So I will fill my graduated cylinder up with water. So the first thing that I need to do in order to measure by displacement is fill up my graduated cylinder to a certain amount. So I've chosen 50 milliliters here. So you can see that the meniscus lies on the 50. And then I'm going to stick my piece of metal in. And the water is going to rise up. And the amount of water that the metal piece is displacing is the volume of my piece of metal. It's taking up a certain amount of space, and that's pushing the water up. So then I read this measurement at 71 milliliters. So the new level of water is 71, and it started at 50. That means that the volume of my metal piece is actually 21 milliliters. So it's whatever is being displaced from the original amount. So now we can use our measurements to calculate the density. Our measured mass of our metal piece was 58.07 grams. And our measured volume was 21 milliliters. So we know that density is equal to mass divided by volume. So 58.07 grams divided by 21 milliliters And if we do the calculation for this is equal to 2.77 grams per milliliter. The piece of metal that we measured was aluminum. And the actual density of aluminum is 2.7 grams per milliliter. So we can see that if done well, this is an accurate measure of the density. You can use water displacement to find the volume of any substance. Let's say I want to find the density of some beads. The first thing that I need to do is measure the mass of a certain amount of beads. I'm not going to do one bead because that's quite variable. So I'm going to do 5 beads, which is 1.15. And then I'm going to do volume displacement for these 5 beads. I'm going to use a smaller graduated cylinder so that my measurements are more accurate. So I put 15 milliliters of water in here. I'm going to plop my 5 beads in. 1, 2, 3, 4, 5. So if we look very carefully at it, it looks like it's just above 16 milliliters, so we'll say 16.2. So that means the volume of my 5 beads is 1.2 milliliters. So now let's calculate the density of the bead. When measured, I got a mass of 1.15 grams and a volume of 1.2 milliliters. And if we calculate this, it's 0.96 grams per milliliter. And this makes sense because the beads were floating. Meaning their density must be less than 1, because 1 is the density of water. Because I measured the mass of 5 beads and the volume of 5 beads, this calculated density is actually the density of 1 bead. The 5s cancel. And that is the way you can calculate the density of objects.